4.5 billion years ago, in a galaxy we call the Milky Way, a cloud of gas and dust began to collapse. And we believe that perhaps that started from a supernova that exploded nearby. That collapsing gas and dust began to form primitive bodies we call asteroids today.
That will go on and on and on to launch.
One such body is Bennu. This is a dark asteroid that we have found and that we're going to hunt down, we're going to orbit, we're going to take a good look at it, and we're going to bring back a sample. This is a fantastic mission.
Thank you, Jim. Before I introduce today's panelists and their briefings.
It is about the size of an SUV. It weighs about 2,000 pounds with the fuel tanks empty. But when we fill up the fuel tanks, that more than doubles the weight to 4,650 pounds. The OSIRIS-Rex will achieve. We have a 1/10 scale model here of the spacecraft.
One of the amazing things about OSIRIS-Rex is it actually addresses all of the science goals that planetary science has at NASA. OSIRIS-Rex is going to help us understand how the solar system works and the nature of the bodies in the solar system. It's going to help us understand how the solar system formed. It's going to inform our understanding for the potential for life in the solar system on Earth and elsewhere. But it also advances our more practical goals of understanding the resources of the near-Earth solar system as well as the hazards.
Analysis of the sample once it returns is about 800.
Our main goal is to collect a sample of an asteroid and return it to Earth. But why was Bennu chosen as the target destination asteroid for OSIRIS-Rex? Well, the science team took into account 3 criteria when making that selection: the accessibility of the asteroid, the size of the asteroid, and the composition.
Okay, let's get started. Hold on to your hats and your chairs.
This is a space rock that is primitive, that dates back to, over 4.5 billion years ago, and it's carbon rich, so we know there's potential for organic molecules to be there within that material we bring back. So it's important because it helps us understand really the formation of our solar system. That's kind of a big deal.
How will you get the spacecraft close enough for the arm to...
We go through actually a series of maneuvers. The great thing about Bennu is it's big enough that we can actually go into an orbit around it. And once we leave the orbit around it, we actually do a series of maneuvers. There's 2 additional maneuvers that we do that both match the asteroid's spin rate and then put us on a trajectory where we go down towards the asteroid. So we actually do take thrusters and push ourselves gently towards the asteroid.
On the phone, sending in your questions.